In this tutorial, we will use DMAP version 2.1 to perform wavelet analysis on monthly SPI data and interpret drought periodicities for Ames and Minneapolis. The two locations are already defined on the Stations tab. Open Data, and then select Download to prepare a consistent rainfall record for both locations. Select NCEP, NCER Reanalysis 1. Set the period from 1970 through 2025. Choose the monthly timescale and select rainfall. DMAP extracts the nearest reanalysis grid cell for each location. Click Start Download. The progress indicator and download log confirm that monthly rainfall has been retrieved and stored for two locations across 56 years. Open the Drought Indices tab. Keep the period from 1970 through 2025, choose Monthly, and select SPI. No multi-month accumulation is selected, so this example uses month-by-month SPI. Click Calculate. DMAP computes SPI independently for both locations and confirms when the calculation has been completed. The table contains the monthly SPI values. Negative values represent drier than normal conditions, while positive values represent wetter than normal conditions. With the calculated SPI results active, click Wavelet to open the Wavelet analysis window. DMAP automatically analyzes Ames. The window combines three linked views: the Wavelet Power Spectrum, the Global Wavelet Spectrum, and the original SPI time series. Use Station to select the location. Significance controls the statistical threshold, while Morlet omega-0 controls the balance between time and frequency resolution. 6 is the conventional default. Run Analysis recomputes the transform. The status line confirms 672 time steps, 30 wavelet scales, and 1 dominant period for Ames. Results can be exported to Excel or saved as PNG charts. The teleconnection analysis button continues to lag correlation analysis. Now examine the Wavelet Power Spectrum, also called the scalogram. Time is shown on the horizontal axis, while period in years is shown on the logarithmic vertical axis. Dark blue indicates relatively weak power, while yellow, orange, and red indicate stronger power. High wavelet power does not necessarily mean severe drought. It means that the SPI series contains strong variability at that time and period. Drought direction must still be determined from the SPI values. The white dashed curve is the cone of influence. Results near the beginning and end of the record, beyond this boundary, are more affected by edge effects and should be interpreted cautiously. Now focus on the global wavelet spectrum on the right. This chart summarizes wavelet power across the complete record, so it shows which periods are most influential overall, but not when that influence occurs. The vertical axis represents period in years, and the horizontal axis represents global power. The blue curve shows the time-averaged power at each period, while the red dashed curve represents the selected significance threshold. A local blue peak is considered significant when it extends to the right of the red threshold. Here, the strongest significant peak occurs at approximately 11 years, matching the dotted line on the scalogram. This result suggests an important long-term periodic band, not an exact 11-year drought cycle. Its timing and persistence must still be evaluated in the scalogram. The significance menu offers 90, 95, 99%, or none. Reducing the level from 95 to 90% makes the test less stringent. Selecting none removes significance testing and dominant period detection. Next, change Morlet omega-0 from 6 to 8 and rerun the analysis. A higher value improves frequency resolution but reduces time localization. The estimated Ames period shifts to approximately 11.8 years. This change demonstrates that a reported wavelet period is an estimate influenced by the selected parameters. It should not be interpreted as an exact, perfectly repeating drought cycle. Now switch from Ames to Minneapolis. DMAP recomputes the station-specific transform. The SPI series, scalogram, and global spectrum all change, although the dominant peak remains near 11.8 years. This shared period can be valid because both analyses use the same discrete grid of wavelet scales. Compare the timing, power, significance, and cone of influence before attributing the result to a physical climate driver. Thank you for watching. If you found this tutorial helpful, please like the video and subscribe to the channel. Stay tuned for future videos exploring other DMAP analyses and explaining how to interpret their results.